who gonna share about SQL Server to PostgreSQL migration. So please clap your hands and welcome the guys on stage. Thank you very much.
Thank you, everyone, and welcome to our session on managing backups, collation, and case sensitivity for SQL Server to Postgres migrations. My name is Roneel Kumar, and I'm a Senior Database Specialist Solutions Architect. I'm based in Sydney, Australia. I actually work across customers with from APJ.
Hey, hi everyone. Good morning. I'm Samir. I'm a database specialist, part of enterprise support organization in AWS. I'm based out of Singapore, and I work with some of our largest customers who are always pushing the boundaries of what is possible with a database. So today what we are going to do is we are going to talk about some of the nuances and challenges that people face and they come across when they are migrating their workload from SQL Server to PostgreSQL. Between me and Roneel, we have talked to at least about 100 SQL Server developers and database administrators in last year or two. And what we are going to try and do today is compress all those conversations in next 40 minutes. Quite a daunting task if you ask me, but we are going to try that nevertheless, and we'll see how that goes. We'll talk about architectural comparisons, then we'll talk about some of the interfacing with the database, like how do you insert data, how do you access data, and then we'll talk about some of the administrative tasks that you need to care about when you're moving over from one database to other database. To get started, I'd like to ask you, Roneel, you work with customers across APJ. Why do you think people are looking for alternatives? Why are businesses, enterprises looking for alternatives?
Yeah, excellent point, man. So basically, customers are looking to break free from the lock-in of punitive licensing and are looking to actually being able to go in and deploy in cloud-native environments if needed as well.
All right, and why do you think PostgreSQL is a good fit for them?
First of all, I would say licensing. I actually come personally from a commercial database background, and we always used to actually go in and think about the pain of actually the licensing to begin with. So with our Postgres being open source, it actually brings with its the cost efficiency being open source and the community-led development. We actually had our colleague Michael Pecchia who actually was talking about Ed Bliss's commitment to the open source community as well. But Postgres in itself actually is, as I said, open source, community-led, and then the flexibility to deploy the database, where customers want it, and gives them the confidence that we won't be locked in, because Postgres, as you know, is owned by a community. It's not owned by any enterprise. And Postgres has many enterprise-ready features that it comes with, and it actually has a healthy subsystem of plugins and tooling around it.
Nice. So let's dive into it now, starting with some of the architectural comparisons. And what we'll get started with is the logical layout of how you structure your data and how it's structured inside the database. So in a SQL Server database, you would typically have an instance which has some special databases, or you can call them the base databases that are already there when you create the instance. MasterDB, TempDB, Model, MSDB, and then you can create a number of user databases. This is where you can store your data, and you can organize that data in basically multiple schemas, and then you have tables within these schemas. This is how you logically store data in SQL Server. How do you do that in Postgres?
So Postgres is also a relational database, so it's not much different. So when you initialize your instance, you get a few default databases. So basically your template databases, template 0 and template 1. So template 1 is very similar to your model database that you actually get within SQL Server. And the Postgres database that you see at the bottom is the default database that you'll get. It is no different than any other user database as well. And you can actually create one or more user databases, and within that schemas, and then logically organize your objects within it.
Right. So not a lot different than PostgreSQL. That's convenient for users to understand. All right. Let's talk about how that data is physically organized on the storage. So in SQL Server, you are going to have basically TempDB, that's a special database. We'll talk about some of its use cases later on. But inside a user database, you're going to have file groups. This is where actual table and index data lives, and then transaction logs. We'll talk about how transaction logs are used for writes, but this is how data is physically organized in SQL Server, on a very high level. How does this happen in PostgreSQL? Is this also similar in Postgres?
Yeah, cool. So Postgres, in that respect, is slightly different, but it is very simple to understand. So databases are more of a logical construct. So if you actually look at the physical directory, you'll actually see that how simple and intuitive it is. So inside the data directory, you'll actually see what's called the base directory, and in it, it'll actually have each of the databases that's created within that instance, and these are actually represented by basically database OIDs that you actually see here. And inside the databases, you'll actually see multiple files, where each file actually belongs to a particular object within the database, and these are actually created in 1 gig chunks. So as soon as it actually reaches a 1 gig size, Postgres automatically will actually create another file for it. And what it also will have is the well directory, right? So pgwell basically means your write-ahead logs, which is equivalent to your log files within SQL Server. And they're actually stored in what's called pgwell. And it actually has you can actually go in and create them on a separate storage as well, similar to what you usually configure within SQL Server as well.
Right, but no concept of a data container or sort of file groups what we have in SQL Server.
So Postgres has what's called table spaces, so you can actually go in and store data on another storage volume. So that's basically where you'll actually have a table space directory inside the base, and you'll actually have your databases within that'll actually exist in separate physical volumes then.
Okay, I guess I have got to agree with you. It's quite simple and intuitive. You have got data inside that database, and then quite neat organization. Great. Let's go to the next concept, that is read caching. Let me talk about how things work in SQL Server on a high level. If you make a user connection and you select something from the database, if the pages required to serve that query are not in the cache, they'll be first read from the cache and then used to respond back to the user query. And as you make more queries that have to deal with rows on the same page, they are going to benefit from the page being in the cache. This is a great performance improvement. How does this happen in PostgreSQL?
Yeah, so more or less, it's basically the same in SQL, in Postgres as well compared to SQL Server. But there are some differences in the way I/O is actually performed, but the concepts are pretty similar.
Right. Okay. Now let's talk about writes. In SQL Server, typically what's going to happen is if I have a buffer cache in the memory, let's assume that it's already there in the memory. If not, during an update, I'm probably going to read it from the disk first. As I do the update, it gets dirty. And when I do a commit, that's when it gets written to the transaction logs. And then I can have multiple transactions hitting the same page or multiple other pages, all of them getting dirty, and they get written to the transaction logs as I commit those transactions. Once in a while, there'll be a checkpoint, and that's when those dirty buffers will be written to the storage, basically your data file, or where data sits in terms of file groups. And these transaction logs can be backed up, which is where which is what I can use for point-in-time recovery or log shipping replication. How does this work in case of PostgreSQL?
Right. So Postgres has something that's very similar, and again, there is differences in the way Postgres does or performs the I/O, but more or less, the approach kind of is the same in Postgres as well. The same concepts of it actually reading from going to memory and then basically going to the data file if it doesn't exist in memory, and then if it doesn't exist rather in memory, it actually goes to the file system to get the file, stores it in memory, and then basically returns the results to the client.
Right. So quite similar concepts like checkpoints and wall archival and those things. Right. Okay. Now, so we talked about the archival of the WAL files, and I mentioned point-in-time recovery. In SQL Server, we have some sort of a concept called recovery model. Can you help compare the recovery model in SQL Server and the equivalent features in PostgreSQL?
Yeah, so by default, Postgres has the WAL settings to minimal, which basically is the equivalent to what we call it a simple recovery model in SQL Server. And it actually means that the WAL files can simply be used for crash recovery in that case. The next we actually have is what's called full recovery model. So in Postgres, that equates to what we call as replica. And this setup actually allows you to set up replication for log shipping to another instance, as well as being able to do point-in-time recovery as well. The third concept that SQL Server has is called as a bulk recovery model. Now, bulk recovery actually gives you performance if you're actually doing bulk loads. Postgres, if you actually look at it, doesn't have an equivalent level to actually that's actually there as well. But we can actually achieve a similar optimization by using synchronous commit to off. In that case, so whilst you're doing the bulk loads, the other method that's actually there is if you actually are using change tracking in SQL Server, it allows you to do change data capture and set up heterogeneous replication, which you can, if you're doing heterogeneous replication, you can achieve that by setting the WAL level to logical in Postgres as well.
Right. Now let's talk a little bit about the memory architecture. So in an instance in SQL Server, you can reserve memory. You can set a parameter that sets the maximum amount of memory that the instance can take, and it can grow and shrink as your workload changes. And the most important component in there is buffer pool. We have talked about how this buffer pool is used for caching, the buffer cache. And this is where data gets cached. And there are other components as well, like log buffers, plan cache, lock manager, and they are shared structures. They are used across all the connections. And then there are per process or per connection allocations in terms of query execution memory or index creation memory. That is how it works in SQL Server. Roneel, can you talk about how PostgreSQL uses the available memory?
Sure. So Postgres has a very similar architecture as well. So Postgres actually also has shared memory. As you know, shared memory caching is going to be common to across any relational database, which is basically a kind of like a fixed allocation that you get for buffer cache, which is used for caching. But the key difference here is Postgres will also have per connection buffers as well as the ability to actually have file system caching, which basically relies, on the file system for your IO operations is there. So basically means if you're actually reading or have data or data files that actually are going to disk, it's able to actually cache it at the kernel level as well. And on Postgres, you typically leave about 50 to 70% of your available memory for your system caching as well. And as I said earlier, there is other shared memory structures for process allocation on the Postgres server. And one important thing to remember is Postgres also actually maintains, your execution as well as metadata execution plans in the respective cache areas as well.
Right. That sounds like a bit of a mind shift change for users when they go from SQL Server to Postgres. It seems like they should reserve good amount of memory for file system caching. Would you say that?
I would say so, and that's primarily because of the underlying architecture of Postgres.
Okay, cool, nice. Okay, thanks. All right, let's talk about TempDB. I said we'll talk about this special database a little bit. TempDB is used, one of the things that it serves is if you are using temporary tables, and if they can't fit inside the memory allocated for caching them, they spill over, and that they get written to TempDB. Second thing they are used for is sorting, any kind of sorting operation. You want to get people who are paid the most. You want to get people sorted by their joining date. If you want to do these kind of operations and it can't fit inside the allocated memory, it starts spilling over to the disk, which is basically in TempDB. It also serves another purpose where it is used for storing old version of the rows, and that is critical when it comes to multiple versioning and concurrency control. We'll talk about that in a bit of, I think, in the next couple of slides. But as you can see, there are a few things that are happening in TempDB. And when I used to work with SQL Server back in the days, one of the things where we used to face contention was on the TempDB and the files, underlying files of TempDB. Is that something users have to worry about with Postgres as well?
Yeah, cool. So this is one of the other things that I actually potentially will say I actually love about Postgres. So Postgres actually stores your temporary objects in your temporary table space, and you can designate any of your user table spaces to handle temporary objects as well. But Postgres will use what's called temp buffers to cache temporary tables and then write them to your temporary files. But sorting happens primarily or first in a memory area known as workmem. And your maintenance tasks, so things like your create index or reindex operations, will use the maintenance workmem memory area. And if the memory is not enough, it'll end up, Postgres will end up writing to your temporary file system on disk as well.
And what about the cleanup?
So the cleanup will actually happen as soon as the user connection closes. Your temporary files that actually get created on the underlying OS will get automatically cleaned up as well.
Oh, that's very convenient. I don't have to worry about expanding the file group or cleaning up these tables. That's easy. That's convenient. All right. Now let's talk about the multi-versioning and how that affects the isolation and concurrency. So in SQL Server, when I am writing something to a row, let's say I'm updating or if I'm deleting, until I have committed, I can't do any read on that same row. And how does that work in PostgreSQL?
Yeah, so in Postgres, when we actually look at options, things like your no-lock options, these are things that don't need to worry about in a Postgres database, and that's primarily because readers don't block writers. And the default behavior, and that's the default behavior as well. And you can't actually even go in and change that as well in Postgres.
Nice. You said something interesting because that's one of the top conversations I get engaged into when we talk to a SQL Server DBA. They ask, hey, do you have a no-lock option? And I say something similar to what you said. You don't need it because readers don't block writers, writers don't block readers. That's very neat in Postgres. All right, actually that is also possible in SQL Server when you use snapshot isolation. And in that case, what SQL Server does is whatever writes are happening, whatever rows are getting modified, or if you're deleting something, the old versions get stored into TempDB. And these old versions can be referred by a select query or a read query that may need to refer to them. Is this what happens in Postgres as well?
So Postgres, that's one of the things that's very different in a Postgres database. So if you're actually familiar with Oracle and your dreaded, snapshot to old era, that's something that you won't see in a Postgres database. And that's because, updates per se are never in place. So it's if you actually go in and do an update, it actually is a soft delete and then a new insert. And deletes similarly, don't physically remove the rows from the tables itself. And the old row versions are left in place, and updates always actually goes in and creates a new version, as I said earlier, which basically means that a select query can work with one of the row versions depending on when it actually started, and that's the underlying architecture of MVCC within Postgres as well.
Right, okay. So let's see how does that affect isolation level. Now there is a lot on this slide. What are a couple of things that you want to call out and highlight on this slide?
I guess the kind of things that I probably want to highlight is both of these databases support the 4 ANSI isolation levels of read, committed, read, uncommitted, repeatable read, and serializable. Even though the snapshot isolation level is not there in Postgres, but the behavior is similar to read committed or very close to that. And one important factor to remember is that Postgres, you'll never be able to read uncommitted data, and you will never see reader-writer conflict within Postgres as well.
Oh, that's nice to build concurrent applications. All right, let's now talk about some of the developer features and how some of these features like accessing data or storing data, how they compare between these two engines. All right. So yeah, Roneel, go ahead. Talk about how you would store numbers.
Yeah, so to begin with, like if you actually store decimal values within the Postgres database where accuracy matters, for example, if you're actually storing interest rate or foreign exchange data, you can actually migrate that using what's called numeric data types within Postgres.
What about integers? Can I use numeric for them as well?
Yeah, so numeric is actually meant for precision. So, for numeric, for integer data, I'd rather use integer or big int depending on the size of the data.
Right. What about scenarios where I'm happy to have a trade-off for better performance? So I'm happy to let go of accuracy in favor of performance. In SQL Server, I can use real or float.
Yeah, so in Postgres, I'd actually use what's called double precision, or in short, double in Postgres.
Okay. And then what about bit data type? Developers use that to store things like, hey, did Samir attend this conference or not? Or was this delivery made or not? So status kind of things. How would you map that to PostgreSQL?
Yeah, that's something that's actually slightly different within a Postgres database. So Postgres doesn't support bit as such. It actually has data type known as bit string. But based on the use case that you just described, in Postgres, I'd rather use the Boolean data type. That's one of the things, though, it actually allows you to store either true or false compared to a 0 or a 1 or a T or a F in using bit in SQL Server. But, this is one of those scenarios where you need to do a data conversion when actually moving to Postgres as well.
Okay, so there is a bit of effort involved there, right? Okay. What about string values? How would you store strings in PostgreSQL as compared to SQL Server?
Yeah, so Postgres supports what's called variable length and fixed length strings, your varchar, your char data types. And you can also have strong, large text objects like, if you actually are storing an article or this whole presentation within, you can use your text data type for that as well.
Right, okay. And is text like a CLOB data type or what is text like?
Yeah, so text, think of it as a LOB data type, I would say. I mean, like for large objects, I would say very large text objects, it'll end up being a LOB data type there.
Okay. Okay. All right. What about nvarchar? I store Unicode characters, like somebody's name in native Thai language or some other Asian languages. If I'm storing that in my database, how would you do that in PostgreSQL? Is there nvarchar?
Yeah. So that I think the Postgres doesn't have what's called nvarchar, but you can still use varchar data types for that. So character accept whatever that you're using will be supported, based on the encoding you use at the time of the creation of the database.
All right. So I don't need to worry about it separately. Okay.
Yeah.
Right. What about dates and times? How do I migrate date or date time or time data types over to PostgreSQL?
I would say dates are easy. So Postgres has what's called a date data time, and so is time. And for time data type, we actually have what's called a date time data type within the Postgres data type, and you can also use what's called timestamp in Postgres.
You mentioned timestamp for date time, but there is a different timestamp data type in SQL Server, and that is deprecated. People now mostly use row version. So how does that become date time in PostgreSQL?
Yeah, that can be confusing, but that is very different within Postgres. So, it's different to the Postgres timestamp data type. And timestamp with time zone is also used to store date and time, similar to date time and date time offset types that you actually use in SQL Server.
Got it. So it has nothing to do with the date time timestamp data type of SQL Server, which is binary sort of data type. Okay, got it. Okay. All right. What about binary data? Because sometimes people use that to store, text files like this presentation in PDF format or receipts. prescriptions. So I can use binary or var binary. Some legacy applications in SQL Server also use image data type. How do I migrate them to PostgreSQL?
Yeah, that is simpler in Postgres. You can simply use what's called the byte data type within Postgres to actually store your binary data within Postgres as well.
Got it. Okay.
Ahmed, like, given your strong background that you actually have come from with the NoSQL and unstructured data, how do you actually go in and think about storing that within a Postgres database, so your unstructured data?
Right. So PostgreSQL has purpose-built data types like XML to store XML values. You can also store JSON data, and not just you can store these data types. You can also query them. You can parse them, and you can even update JSON data. There are JSON operators, XML functions, JSON functions that allows you to operate and deal with that data.
Nice. So what about your geospatial data type?
All right. The geospatial data types. Let's pivot a bit. Let me talk about a different concept. Postgres has this neat concept called extensions. And it does what it sounds like. It extends the capability that are not available in the core. And there are some extensions available which adds new data types and operators, functions that you can use with those data types. Even index access methods that allows you to index those special data types. And one of them is PostGIS. And what PostGIS do is allow you to store location data, like the location of this conference, or the layout of this hall, where points are, as in where chairs are. All this kind of information you can store inside with purpose-built data types that are provided by PostGIS. And it's one of the most popular extensions,
Nice. So what are some of the other cool extensions that you can, highlight to our room that's going to be important in Postgres?
One I can talk about is PG Vector. It's another popular data type that's out there. It's relatively new as compared to PostGIS, but it's getting a lot popular. It allows you to store vectorized information. So if you have vector embeddings and you want to store them, index them, query them, you can do that with PG Vector.
Awesome. So what about managing your auto-incrementing sequences or your auto-assigned unique identifiers?
Right. You can use serial data type, which basically uses a sequence underneath, or you can use generated always as identity columns, and you can specify the incremental steps or starting step. And when you use these columns or these designated definition against the column, what happens is as you insert rows, these rows are the column value is auto-generated. Another option for you is to use UUID SSP extension, which adds UUID data type, and then as you insert values, they generate UUID with a bit of randomness in it. That helps avoid any kind of contention on the sequences. All right. Let's now talk about sorting and collation for a bit. Let me talk about SQL Server first. SQL Server supports case-insensitive and accent-insensitive collations, which is helpful when you need to search for a value and you don't know how was that value initially stored in the database. From practical use case perspective, back in the days when I was dealing with banking and anti-money laundering applications, this used to be extremely helpful for dedupe checks or checking for a user when I don't know how exactly their name was stored. And as you can see, based on the collation, I would get the data out from the database with my select query, irrespective of what case I use in my where clause. Now, one of the things with collation in SQL Server is it is not just about the data. Your metadata also follows the same collation. That means if I have a table called person and I use case-sensitive collation, when I query that table with capital case, it's going to fail. So I have to be very careful in what case I specify even in my queries. What about Postgres? Can you talk a bit about Postgres?
Yeah, cool. So in Postgres, all metadata by default is stored in lowercase. And even the query processor will actually convert all of your identifiers, like your table names, your column names, to lowercase. And then, when you use query that uses mixed case or capital case, in that case, it will work fine. Unless, you go in and code the identifier. And you can code the identifiers if you actually use, if you want to preserve the case of the identifiers in that case. And it is a good practice, so to speak, in Postgres to actually avoid mixed case or what's called camel case when you're actually naming tables or columns. And if you want to have tables with the same name for, for example, different modules, if you've got accounting schema, in your HR schema, if you actually want to put, an employee table that exists in both those schemas, both those applications rather, you can put them in schemas to actually differentiate the tables in that respect.
Got it. What about handling case-insensitive search in Postgres?
Yeah, you can use what's called the lower function, which works great, but you can also use what's called the like operator within Postgres as well. But if you're migrating from SQL Server to Postgres, changing code can be a lot of effort in that respect. And an option to actually reduce the migration effort is to use the CI text extension that adds the CI text data type within Postgres, and all the string operations in that case become case insensitive like SQL Server. So you can also go in and index your CI text columns, and you can also choose your data to be case insensitive by setting your database collation at the time of creation of the database. And now with the addition of the ICU collation, it is much simpler. So it actually goes in and adds the capability to simply create or specify the collation, and you're actually able to use that source data as well as the correct classification behavior at the column level without having to recreate the database.
All right. Let's quickly talk about accessing data. I know we are running short on time. All right. In SQL Server, let's talk about authentication and authorization very quickly. You got a super user. You first connect using that super user, which will basically go ahead and then create a new login. Then you have got to create a user for that login in specific databases that it should be accessing. That basically controls what databases it can access. And then at the table and schema level, you can specify specific grants. So you control what schema and what specific tables this user can access. How does this work in PostgreSQL?
Yeah, so Postgres is slightly different. There is no separation of users and logins. So roles that can log into a database are basically called users. And similar to our previous SQL Server steps that we actually saw earlier, when you connect to our database, we connect to the Postgres database. And on the Postgres port as well. But you also specify the database name, which is why when you create your database instance, you actually get the Postgres database by default. So once you actually have your connections created, you actually go in and create a user with your appropriate password, grant your permissions to the user to connect to one of those, one or more user databases that's there. Then you actually go in and grant your appropriate permissions on the schemas, and then the permissions on the respective objects that you actually have. And if you actually have multiple databases, obviously you actually need to go in and repeat those steps across all those databases as well.
All right. Let's talk about data access and federation. So if you've got a table inside a database, you connect to that database, select star from that table. You can use schema or a table name, and that will give you access to that table. If you want to access data in a table that is in a different database within the same instance, you can use this three-part name, which is database.schema.table name. You can also use linked servers. These linked servers allow you to access data in another SQL Server database or even other heterogeneous databases like MySQL, Oracle, and then you can query them. How does this work in PostgreSQL?
Cool. So in Postgres, you can connect to your instance by specifying a a database name rather, and then you actually go in and run your select queries on it. But the Postgres database is a lot more stricter in that aspect of, you won't be able to make a cross-database query on that same instance as well, the way you described, by using a three-part name in SQL Server. So if you actually want to use or connect to a separate or different database from the one that you're connected to, you'll need to actually establish a new connection using what's called a foreign data wrapper. And you basically, a foreign data wrapper allows Postgres to interact with other external databases as well, other relational databases like SQL Server, MySQL, Oracle, and Postgres as well. And properly configuring your foreign data wrappers enables seamless data access without having to migrate the data and making it an ideal solution for hybrid environments as well. And you need to set up the foreign data wrapper server as well as the foreign table for you to actually be able to make that query to actually access the table as well.
Okay. All right. Now, quickly talking about the access methods, PostgreSQL is SQL compliant, right?
Yeah. So Postgres is a SQL compliant database, and most of the query patterns that you'll be using is SQL Server that you use are actually available on Postgres as well. And the catalog for functions for your string operations, for your type conversions may differ, but you also need to rewrite your TSQL code to something like PL/PG, PGSQL, or your stored procedures as well.
Right, so that means there may still be some effort involved in migration, even though the syntax is similar, it is not exactly the same, right?
Yes and no. We actually launched what's called a Babelfish extension that allows, in your migration complexity and being able to migrate your TSQL code to Postgres a lot more easier. We'll talk about Babelfish slightly later.
Right.
As well.
Okay. Let's talk about some of the administrative tasks. Starting with backup, in a SQL Server instance, you can use Management Studio to generate a logical backup, which is basically a create script that is portable. You can also take physical backups, which can be full or incremental, and then you can set up log archival, which then works for point-in-time recovery. Can you talk about backup options in Postgres?
So Postgres supports logical backups using what's called pgdump, allows you to actually dump your data, and it is portable through versions and supports multiple formats as well. And you can actually go in and do full backup with what's called pg-based backup. It is a physical backup tool in Postgres that allows you to create the binary copy of the entire database cluster, including your data files, file segments, and configurations. And with Postgres 17 now, it allows you to use incremental backups using PG-based backup, which is basically similar to your differential backups in SQL Server.
Got it.
And you can use your archive logs to basically go in and do change data capture or point-in-time recovery within the database as well.
Okay. All right.
And in Postgres, you also get the concept of, as I talked about, foreign data wrapper. So if you actually want to access external data files using CSV, or you can actually also use copy commands to load data, or PG loader for bulk loading of data within the Postgres database as well.
All right. And I think replication-wise, all the different replication topologies of SQL Server are also supported in Postgres, right? Log shipping, change data capture, and even always-on sort of architectures are possible. Is that right?
Yeah, absolutely. I mean, there's a lot on this slide, but yeah, just to summarize, you'll actually get, almost equivalent replication features. You'll actually have things like if you use transactional replication, you can use logical replication and all within Postgres as well.
Okay. Cool. All right. I'll quickly go to the next slide, which is on maintenance. And
yeah. So if you look at things here, SQL Server and Postgres both have different administrative models. So tasks such as your database monitoring, indexing, and monitoring need to be adjusted when you're actually migrating from SQL Server to Postgres. And Samir, one of the important things in Postgres is vacuuming. So would you want to actually just quickly highlight the concept of vacuuming in Postgres?
Right. So this is something that might be new for people coming over from other databases. Something that is not new is updating statistics. Every database needs to work with statistics. That's how planners work. But what's unique in Postgres is because how Postgres creates multiple versions whenever you update. Because of that, because of maintenance of those multiple versions, you need to clean them up at some point in time. And that's what vacuuming does. These multiple versions, the way they are versioned is using transaction ID. So as you create more versions, you're exhausting more and more transaction IDs, and you need to clean them up as well at some point. So auto vacuum does that as well for you. All these things can also be done manually. So you could also run them as a manual task, but ideal would be to tune auto vacuum settings and maybe schedule these vacuum tasks for once in a while. That's something very important for people coming over from SQL Server. From monitoring wise, do you want to quickly cover that?
I think we can, just in the interest of time, I think we can see there's equivalent DMV functions that we actually have in SQL Server, and we can actually use those in Postgres as well. Things like your wait events, your logs, your database queries, you can actually use similar DMV functions in Postgres as well.
Right. Now, that we have covered most of the administrative tasks, do you want to touch upon the migration approach quickly?
Yeah, sure. So if you actually look at the migration approaches, we can use the first step of actually doing a database migration is basically your schema conversion, which involves migrating your database objects. Next, you'll actually go in and do your data migration, which involves you either using a data export import or using change data capture, as we talked about earlier, using archive logs to reduce downtime as well. And the next phase will be actually one of the most critical, where you need to ensure that your Postgres database behaves or application behaves the same as what it did in SQL Server in terms of your functional testing, and then you'll actually do your performance testing. So your Postgres database should actually be able to at least be able to perform at the level what SQL Server was doing on Postgres, or you need to do some sort of retuning, some sort of query rewriting to ensure that your database performs the best as well. And once you've actually done, you can actually go through with your cutover steps.
Now, let's talk about tooling available, and there are a lot of tools and things that are available to you when you want to migrate as an administrator. Is there a particular plugin or a tool that you want to call out from this slide, Roneel?
Yeah, so these connectors tools that's actually there. One of the common tools that we use at AWS is Babelfish. Babelfish, as I mentioned, is a migration accelerator tool that we AWS launched. It is available as an extension to open source Postgres as well, and it allows the Postgres database to basically be multilingual. So it understands both SQL Server as well as Postgres at the wire level.
Nice. With that, we kind of wrap up our presentation. If you're keen to explore PostgreSQL as an alternative to your workloads on SQL Server, go ahead, use these resources. There is documentation, there is help that you can get from mailing groups on PostgreSQL, and you can try out Postgres on Amazon RDS free tier. Thanks, everyone. I think we are at time.
We're going to have time for one question quickly.
All right.
So this gentleman here would like to ask a question.
Samir, you touched upon the heterogeneous logical decoding. So
Right.
What did you have in mind from a replication standpoint?
Right. So in SQL Server, people typically use change tracking, and with SSIS, they can do heterogeneous replication topologies, which means basically SQL Server replicating to other databases. Some people also use federation, and they use linked servers when they want to access data on other databases or other data storage. In PostgreSQL, what you can do is logical decoding, and you can replicate data into Kafka or another PostgreSQL database, or even something else altogether, which is not a data store that you're typically familiar with. You can do all of that by using logical decoding in PostgreSQL. You can also use foreign data wrappers, which allows you to set up federation. And this is typically important these days because very rarely data sits in silos. You're going to have data that is connected to other data stores and other patterns. Sorry, you had a point, Michael?
So you didn't mention in your talk anything about encodings. Is there any kind of difference that users have to go through when it comes to a specific encoding that your that the SQL Server is using when they migrate to PostgreSQL, or they just use UTF-8 usually? Do you have any comments of pain points that people know that could be even made better in Postgres when it comes to that?
Right. We touched upon that a little bit. In SQL Server, there is a data type called nvarchar that typically users use to store UTF or Unicode characters. In Postgres, you want to make that decision when you're creating the database by choosing the right encoding and the character set that you want to use. And remember, it's a one-time decision, so you can't go back on that. So ideally, it's better to use UTF or something that is more generally encompassing of different character sets that you're going to have to deal with. Yeah, that's a good point.
Great, I think we're up for time. So Samir, Roneel, thank you very much for that deep dive into
A big round
all
of applause
things.
to Samir and Roneel, everyone. Thank you very much.